Hi, I'm Bruce, and welcome to my Baptronics Mountain Labs here in Colorado. Today we're looking at the third of my BK1856 1.3 gigahertz counters. These units have all been in beautiful shape. Um, I would say not a scratch on them. And the cases are shiny, plastic looks new, front panels are not scratched. They really don't look like they've been used, but I assume they have been and that they've just been taken very good care of. I don't know anything really about their history, but I can tell you that they've calibrated well and they function beautifully, and we're going to take you through a series of checks just to prove that out. Right now I'm connected to my rubidium standard, which is the silver unit with that little tube sticking out the front up there. And we got a 10 megahertz signal coming in from that standard. And right now I'm stepping up. We're at the 0.1 second gate, so we're reading 10 megahertz to within 10 hertz, and then we go to within a hertz. And then we're going to go to a 10-second average, and that'll take us to the 10th of a hertz, and we'll just see how far off we are. What should happen? We'll shove over to the right. So as you can see, we are reading 9,999,999.8 hertz. So we're 0.2 of a hertz off, and just a moment ago I saw it actually float to a 9 and we were a tenth of a hertz. So we're probably 0.16 hertz off, something like that. Yeah, there we are again. We're 0.1 hertz away. So as you can see, we're in good calibration here. And what we're going to do now is to see how we perform at the extremes of its range. On range A here, we're supposed to read 5 hertz to 100 megahertz. And then we go to range B, we read 80 megahertz to 1.3 gigahertz. So right now we're on range A. Let's go ahead and we'll test the 100 megahertz range, see how we do. I am feeding my input from this PTS 500. All right, that would be 100 megahertz right there. And let's see how we're doing. All right, we got 100 megahertz. And we want to find out how we do on the low end. We're going to have to connect to an audio source. So we'll go to this HP3320 frequency synthesizer, and we will dial in 5 hertz. There we go. And as you can see, we are reading 5 hertz. Now if I go ahead and put myself in a 10-second average, we'll pick up one more decade. But we gotta wait 10 seconds to see it update, so we should see 0.005 and then whatever is after that, which in this case it's a 0. So we are reading 5.0 hertz. Since we're here, why don't we take a look at period? And for period, we're getting about, looks like an average of 200,000 microseconds, which would be 5 hertz. If I go to a little slower, longer range here, we'll get less jumping around, and we see that we are 199,999 to 200,000 So 200,000 microseconds. Get a lot more resolution this way. If you were to take 1 over this 200,000, you're going to get a whole lot more resolution. Okay, let's move on to channel B, because we've just done A. And let's see if we can read our 80 megahertz to 1.3 gigahertz. Bear with me while I set up. Okay, as you can see, we've got 80 megahertz on this HP8640B. I'm going to turn the output on. Okay, we got a signal coming through. And we see that we have 80. No problem. Give ourselves a little more resolution. We can go to a 1 second time average. And we see 79.9999, which is, there we go to 80. It's 80 to 4 decimal places, and my HP is to 3 decimal places, so very nice indeed. Now let's go ahead and take ourselves up to the 1.3 gigahertz and see if we can get that. In order to get that, though, I'm going to have to use a doubler. This unit will go to 512 megahertz as is, but with a doubler we'll get up to 1024. So here's our doubler. We'll go ahead and turn ourselves up here. Take our lock off. Alright, in this position we are actually doubling the frequency in megahertz on the unit here so that it matches what comes out of the doubler. Really putting 320 megahertz into the doubler, but we're going to go ahead and read this up to as high as we can take it. Alright, we just got to 1.09973 gigahertz, so 1099 megahertz, almost 1100. So let's see what we get over here. And we have 1099.7245. So we're right there. No problem reading the nearly 1.1 gigahertz signal on this 1.3 gigahertz device. So not only is it a good looking unit, it performs. Now we took a look at the period a moment ago. Let's show a few other features here. And put ourselves back on A. Right now we're reading 10 hertz. And I'm going to put myself into the totalize mode. That's the period. What's the period of 10 hertz? Hundred thousand microseconds. 1 hertz in microseconds would be 1,000,000. 10 hertz would be 1/10 of a million, which would be 100,000. So we're getting the 100,000 microseconds, no problem there. Let's go to totalize. What we see is we're counting our 10 hertz frequency, summing it up. And at any given moment, if we decide we want to, we can hold. So we see we have 163. Now it's actually counting in the background. When I release the hold, it'll pick up from where it is. I can reset it. So we can see that our totalizer function's working. Now there is inputs in the back that would allow you to put a start and stop signal in for the totalizer so that you could measure, say for instance, time intervals and things like that. So another handy little function the thing has. So everything is here. It's all working. We have the gate light. You've got a kilohertz or microseconds light. You've got a megahertz light. So if I put myself in kilohertz, my reading's in kilohertz right now, you see it lit. If I go to megahertz, my reading's in megahertz. You see, at 10 hertz you're not going to see anything, but at least you know that's what we're trying to read. And the last thing is the check function. And in the check function, I look at the time base that's within the unit, and we count the time base over a 1 second interval, and we see that we get 10,000. And right now I'm in a 0.01 second time base. If I go to the next range, we pick up another decade. We go to the 1 second, I get 10 million. And that would be to the hertz what the time base has. And you can see that all of my displays are working. It's a quick check, and that's why it's got check marked on there for 10 megahertz. Okay. And along with that, we're going to include the BK1856 manuals on CD, along with the schematic diagram for the 1856 and the components list. So if you need to refer to how to use the unit, or if you need to do some service in the future, you're not left without. It'll come with the power cord. It's a brand new power cord. I opened up the package myself just a few minutes ago, and I'll put it back in the same package and you'll get it. So thank you for listening, and happy bidding.